Welcome to the next session on operations research. In this session, we will discuss about the various game models. Game theory employs various game models to represent and analyze strategic interactions between rational players. These models help to formalize situations in which individuals make decisions that affect each other's outcomes. Each model type emphasizes different aspects of the game, such as timing, information, and cooperation. Below is the major game models used in game theory. The first one is normal form games. It is also called as strategic form games. In a normal form game, players choose their strategies simultaneously without knowing the strategies of the other players. Representation, it is typically represented using a payoff matrix where rows and columns correspond to player strategies and the cells show the payoffs for each combination of strategies. For example, prisoner's dilemma. So here there are players which are two prisoners. Strategies will be to cooperate or betray. Payoffs will be based on whether both cooperate or betray, or one cooperates and the other betrays. So we know that suppose if there are two players X and Y, it is possible that X and Y both have chosen to lie. So it is a case where both of them will still win. So both are deciding to lie. It is possible that X has decided to say the truth and Y has still decided to say the lie. So what happens is X will get a lesser punishment and Y will get a severe kind of punishment. It is possible that both of them have decided to say the truth. In that case, both of them will be punished, but the punishment could be of a certain level. So this is what happens when they either cooperate or they betray each other. There will be payoffs based on what they have decided to play. Application. This model is useful for analyzing one-shot simultaneous decision games such as market competition, auctions, and some political scenarios. Next is extensive form games. Definition. In extensive form games, players make decisions sequentially and the game is represented as a game tree. Players observe some or all of the previous moves before making their decision. Representation, a tree-like structure where each node represents a decision point and branches represent possible actions. Payoffs are listed at the endpoints leaves of the tree. Key example is chess. There are two players, black and white. Strategies are each player makes moves one after the other. So that is the use of the term sequentially. Payoffs, win, lose or draw depending on the sequence of moves. So at a time you can still go behind and you can check where the players have started from. Application used for games where timing and the order of moves are crucial, such as chess, checkers and negotiation processes. The third one is repeated games. Definition. Repeated games involve playing the same game, often a normal form game, multiple times in succession. Players can adjust their strategies based on the outcomes of previous rounds. Representation. These games can be modeled as an extension of normal form or extensive form games, but with additional rounds and a focus on strategies that evolve over time. Again, the example is of prisoner's dilemma, but it is of iterated type wherein you will be constantly asking questions. There will be multiple rounds of question answer session. Players are again two prisoners. Strategies will be cooperate or betray in each round. Payoffs determined by repeated outcomes across multiple rounds. So once you have many rounds of question answer session, you will come to know whether the truth or the lie is still going on and which player decides to betray, or if the two of them decide to constantly remain in same cooperated sync and go till the end. So you would get to know the results. Application. This model is relevant in long-term strategic interactions such as trade negotiations, business competition or evolutionary biology. where ongoing relationships matter. The fourth one is stochastic games. Definition: in stochastic games, the game progresses through various states, and the transition between these states depends on the player's actions and some random element, that is, chance. Representation: like extensive form games, but with a probabilistic component where players' actions may lead to different game states with certain probabilities. Example is Markov decision processes, a type of stochastic game. Players, one or more decision makers, strategies, choose actions that maximize long term payoffs considering the state transitions. Payoffs depend on the current state, the action chosen, and the probabilistic transitions. An example for Markov decision process could be a robot that is being trained to move around the house without crashing. A reinforcement learning agent is the entity which we are training to make correct decision, that is the robot. The environment is the surroundings with which the agent interacts. For example, the house where the robot moves. The agent cannot manipulate the environment, it can only control its own actions. In other words, the robot cannot control where a table is in the house, but it can walk around it. When I talk about the state defines the current situation of the agent. This can be the exact position of the robot in the house, the alignment of its two legs, or its current posture. It all depends on how you address the problem. The action will be the choice of the agent to make current time steps. For example, the robot can move its right or left leg, raise its arm, lift an object, or turn left, right, etc. So, this is how a Markov decision is being used to train a robot. It is used in reinforcement learning. Applications useful in economics, operations research, and artificial intelligence, where decisions are made under uncertainty. Example: financial markets, resource allocation. The next one is Bayesian games, games of incomplete information. Definition: in Bayesian games, players have incomplete information about other players' characteristics such as their payoffs, strategies, or types. Instead, they have beliefs or probabilities about these unknowns. Representation: Bayesian games are modeled like normal form games but with additional layers to account for players' private information and beliefs. For example, auction games, players, bidders in an auction, strategies, bid or pass, with different valuations of the auctioned item. Payoffs depend on winning the auction, but players have incomplete information about others' valuation. So I think everyone is aware of the auction games where, say, a particular house is being auctioned. Many players come together, they want to buy the house at a particular price which they have already brought with themselves. So what happens is these bidders, they are going to bid for a particular price which is being quoted, and then they keep on increasing the bid such that they get the house, and the others try to bid against the first one such that they will get the house. So that is how the process goes. No one is aware of the money that the other person has decided for the house. I mean, everyone has a budget beyond which no one would pay for the house, and that's how the game continues. Application: this model applies to scenarios like auctions, negotiations, and any situation involving asymmetric information such as insurance markets or bidding processes. The next one is evolutionary games. Evolutionary game theory focuses on the dynamics of strategy changes in populations over time, driven by the relative success, that is, payoffs, of strategies. Players are usually modeled as members of a population, and strategies that perform well reproduce more. Representation: instead of players choosing rational strategies, strategies evolve according to rules like natural selection. So let's see an example of the hawk dove game. Players, animals competing for a resource. Strategies: hawk, aggressive, or dove, peaceful. Payoffs depend on whether both are hawks, both are doves, or one is a hawk and the other is a dove. Application used in biology to model behaviors like competition, altruism, and cooperation. Altruism means when you are more giving towards the other person, and in social sciences to explain cultural evolution and social norms. The hawk dove game is a game theory model that describes a conflict between two strategies, hawk and the dove, that compete for a shared resource. So that is what is already mentioned over here. The hawk is going to represent a selfish fighting strategy. The dove will represent a cooperative sharing strategy. So in this model, what happens is some individuals, they benefit from the selfishness at the expense of others. The model can be generalized to include more than two players and can also include a third strategy, retaliator, which can act as either a hawk or a dove depending on the situation. It is used to investigate the conditions that favor the evolution of pro-social behavior. Some of the mechanisms that can help pro-social behavior evolve include retaliation, conditional dispersal, and relatedness. So we can take an example like teenage boys who are driving at each other. In this classic version of the game, two teenage boys drive at each other at full speed. Whoever swerve first is considered a chicken, while the other is a winner. If neither swerve, they crash into each other. The next one is cooperative games. Definition: in cooperative games, players can form coalitions or alliances to improve their payoffs. The focus is on how the players divide the joint payoffs among themselves. Representation, often represented by a characteristic function that assigns a value. The total payoff to each possible coalition. For example, bargaining games. Players, two or more players negotiating a division of a resource. Strategies, negotiating or make offers. Payoffs, determined by how they divide the resource or outcome. So bargaining game is something that everyone must have involved themselves into at some point of time in their life. It is all about two people. Say there are two players, A and B. Player A has $100 with himself. He has to divide this $100 amongst the two of them. He can keep $99 to himself and he can just give $1 to B, or he can give $50 to himself and $50 to B, or in some ratio. Now in this case, what happens is, based on the behavior of B, this division will be done. Suppose if the first case is considered, A decides to keep $99 to himself and give only $1 to B. B anyways has to accept because he is not dividing the money. So he can happily keep the money and let A take $99 to himself. Or he may disagree and no one gets anything. So in the next situation, this division can happen in any proportion. But what has been found according to psychology is that A tries to give off 50% or say 45% of the money such that B is convinced of the division. So it is possible that this is the chosen one and not the first one. B will not be satisfied with the first choice that is given here. Application used in political science, economics, and business to model partnerships, alliances, and collaborations where joint outcomes need to be divided. So it could be even a partnership in a particular company where two people are investing their time and energy and money into it. So it is possible that they decide to be a partner of 50-50, or maybe one takes up 45% and the other takes 55%, and accordingly they decide to divide their share. The next one is zero-sum games. Definition: in zero-sum games, one player's gain is exactly equal to another player's loss. The total payoff in the game is constant and players are in strict competition. Representation: these games can be represented in normal or extensive form, but emphasize that the sum of payoffs is zero. For example, poker or chess, when only win or loss is considered. Players, two competitors, strategies, choose moves or bets to maximize gains while minimizing the opponent's gain. Payoffs, one player's win is equal to other player's loss. So this is the actual idea of zero sum game. Zero sum means addition is going to be zero. One has lost, one has won the game. Application applied in competitive situations such as betting games, military conflicts, or markets with perfect competition. Next one is non-zero sum game. Definition: in non-zero sum games, the total payoff can vary and both players can gain or lose together. The outcomes can result in cooperation or competition depending on the player's strategies. Representation: these games can also be represented in normal or extensive form, but the focus is on how the total payoff can be positive or negative. For example, the prisoner's dilemma, which is the example again over here. Players to players, strategies is cooperate or betray. Payoff will be cooperation leads to mutual gain because they both have decided to cooperate and not tell the truth. So accordingly, they will be in a gain situation, while betrayal leads to a suboptimal outcome for both. Now, suppose if one betrays and the other is still sticking to saying the lie, then it will be a situation where the person who has told the truth may be given a lighter punishment and the one who has not accepted to the crime will be given a severe one. Application: these games are important in economics, diplomacy, and environmental policy where mutual cooperation can benefit all the parties. The 10th one is symmetric versus asymmetric games. Symmetric games, players have identical strategies and payoffs for choosing the same strategies. The game's rules are the same for all players. For example, rock, paper, scissors. So you have the choice. At the same time, both are going to reveal their cards. So you can just play either rock, paper, or scissors. Asymmetric games, the players have different roles, strategies, and payoffs. Example: the ultimatum game, where one player proposes a split of money and the other can accept or reject. So, like I told you in bargaining game, in ultimatum game also what you can do is you can share the money. Say there's $100, two players are dividing. The second player can decide to take the money or reject it. In that case, both the people will not get the money. Each of these game models allow for different forms of analysis and is suited to modeling various strategic interactions in economics, biology, politics, business, and more. So with this, I end the session on different game models in game theory. If you have any doubt, please write to me in the comment section. Don't forget to like, share, and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.